Hey guys, welcome back to my YouTube channel. So let's get right into it. So I will start by explaining the GrassFire algorithm, also known as breadth first search algorithm. The algorithm is used to calculate the distance from the source point to all other points, but it does not guarantee finding the shortest path. When the program initiates, it looks for a neighboring node. Now, for this case, I will show you a uh, diagram that is given to me in my assignment. And as we can see, for this, I will actually show you my PPT that I have created slides for, which will help us a lot. When the program initiates, it looks for its neighboring nodes. In this case, those are D, E, and P. The distance from the start node to the P node covers the least distance, so that becomes the primary choice. However, the distance between P to Q is 15, which means the distance from start to Q node is 16. On the other hand, if the program moves from E to R, it loses less distance and moves towards the goal node. From R node, its neighbor node is F, which costs 2 distance. If the program moves towards F node, it takes the least distance from the start node to F node, which is 11. The program choice of path is based on the principle of selecting the path that covers the least distance and moves towards the goal node. By selecting this path, the program finds the shortest path from the start node to the goal node in just 11 steps. This detailed explanation of the GrassFire algorithm provides insight into how the program works to find the shortest path and how it makes decision to optimize its path. All right. So now I will start explaining you Dijkstra's algorithm. It allows you to find the shortest path from the start node to the every other node. The first information we need to keep track of the node is that we have not visited yet. So we first mark all the node as unvisited. We create two lists of unvisited node and a list of visited node which is empty of the beginning. In the second step, we assign all the nodes to tentative distance that will change over time. So now for this, I will also like to show you a table that is created on my Word document. The first node to be visited is start node. In the table, I have shown the distance is 0. That is no previous node as it starts um, as it is on the starting node. Now, as the neighbor of the start node are P, E, and D with the distance of 1, 3, and 9 respectively, they are entered in the table with previous node as start or S as shown. Now, selecting the node with minimum distance, which is P, the P node will be visited and entered in the visited list. Now, further exploring the P node, which has one neighbor Q with the distance 15. The distance of Q node is calculated from the start node that is 16 and the previous node is P which is entered in the table. Now again in the table is scanned to find the node with minimum distance. So node D is explored and its neighbor B, C and E are entered in the table with distance of B that is 3 plus 1 equal to 4. For C, it's 3 plus 8 equal to 11 and E is 3 plus 2 equal to 5. Now E is already entered in with distance 9. But as we have less distance, so the node E is updated from the distance 9 to distance 5 and the previous node is also updated to D. Moving further and exploring the next visited node B which has the distance of 4, its neighbor uh, its neighbor is entered in the table. Now next node is visited in E node and its neighbor R and H are entered with the distance of 5 plus 2 7 and 5 plus 8 13 respectively. After this node A is explored as it has no neighbor. Next node R is explored which has one neighbor, uh, that is our F node. The distance is 9, and now F is explored which has one neighbor, that is goal node. The distance for node is 9 plus 2, that's give us 11, and then H with distance 13. Now, after the table is complete, for each node, we can find the shortest path by backtracking. We will start with the goal node and look for the previous node of it. If it is F node, now move to the F node and look for its previous node. It's R node. Now go to the R node and we see E is the previous node. Thus, seeing the E node, we look for the previous node, which is D. Lastly, the previous node of D node is start node. Now we are ready with the path. The path is start, D node, E node, R node, F node, and goal node. Thank you guys.